Hello everybody, welcome back. This is lesson 4 in Unit A, titled Physical and Chemical Changes, Properties. So let's get into it. In the last video, we talked about filtration, distillation, chromatography, evaporation, and other separation techniques, and we had said that some of these things are dependent on the physical properties of these objects. And we said, we'll get there later. Well, now is later. Let's get into what these physical and chemical properties are, and then what physical and chemical changes are. So first things first, let's start with physical properties. And a physical property can be defined as anything that can be observed without changing the composition or chemical makeup of the substance. So generally you're going to use your 5 senses, so sight, hearing, taste, smell, and touch, to come up with these observations. Now, some examples of physical properties include color, texture, density, conductivity, change in state, so all of your phase changes, solubility, malleability, mass, volume. And so these little things with these asterisks, these little stars, are things we're going to get into today in this video. Basically, these are all pretty basic observations, measurements that we can make on our object. So just to go over the few maybe unfamiliar terms, conductivity is a material's ability to allow electricity and or heat to flow. So we'll get into how actually electricity works later on, but as long as you know if something can conduct electricity, if something is conductive, heat and electricity can flow through it. Malleability means something can be shaped or hammered without breaking. So gold, for example, is the most malleable metal. It's able to be shaped and molded into different shapes without breaking. You're able to kind of bend it without it snapping. If you tried bending, I don't know, a plastic roller, it only bends so much and then it snaps. So that is, malleability is also a property of metals, and we'll get into there when we talk about the different types of elements. But right now, malleability can be shaped or hammered without breaking. Freezing point seems pretty obvious, is the point in which a substance freezes. And so in case you forgot, freezes means to go from a liquid into a solid. So if you have liquid water, you want to make ice cubes, you freeze it, and different substances have different freezing points. Boiling point, just like freezing point, but as obvious, but obviously very different. Boiling point is when something boils, and a boil is when a liquid becomes a gas. So if you ever boiled water to make coffee, tea, pasta, all those bubbles is that water, that liquid water becoming water vapor or gas water. So every substance has its own unique boiling point, and table S in your chemistry reference tables, which will be your best friend in this class, has the boiling points for all of the elements. Melting point is when a solid turns to a liquid, so melting point, solid to liquid. If you have ice that is melting, you have solid ice melting into liquid water. Those boiling points are also on the Those melting points, rather, are also on the reference table. And melting point, fun fact, is the same thing as the freezing point. So right now I'm just going to drop that bomb of information, let you think about it. When we get into thermochem later on, we will revisit this semi-mind-blowing fact. So think about that for now. Another physical property is density, and we'll spend some time in the next few videos going over density, the formula, and whatnot in more detail. But different things have different densities, and this is also a value on table S, which we will get to. Density can be used to test for purity for a substance, because if we know what a density should be, if we think something, let's say, is iron, and we know its density is X, if the calculated density for that new sample, if it's not X, we know that it's probably not pure. Again, things we'll get into more detail when we get strictly into density. Now, here's part of table S. We spent a few minutes talking about the different values on it: melting point, boiling point, density. All of these things we'll get into later on. But you have all of these element names, their symbols, their atomic numbers, and the different values for all of these things. So there's no way you need to memorize all of this, like, oh, what's the boiling point of tungsten? No one's going to ever ask you to memorize that because it is on the chemistry reference table. And if you've taken earth science, you're able to use your reference table on any quiz, any test. This is not stuff that needs to be memorized. Okay, moving on to chemical properties. Chemical properties describe the ability of a substance to undergo changes in composition or chemical makeup. So chemical properties can kind of change the way a substance is. So during chemical reactions, kind of evidenced by their properties, you have a new substance that is produced. And so some chemical properties that exist are reactivity, toxicity, pH, flammability, oxidation. pH has its whole unit later on. Oxidation has a whole unit later on, which we'll get to. But I just wanted to go very quickly into reactivity and flammability. Now, flammability is a material's ability to burn in the presence of oxygen. So if something is flammable, given the right input of energy and the presence of oxygen, it can burn. That's why some things are very flammable. It means they can react very easily with oxygen and enough heat energy to become fire. And next is reactivity. And reactivity refers to how readily a substance combines chemically with other substances. So how likely something is to react or not to react. And so here we have lithium metal, sodium metal, and potassium metal in water. And lithium, bubbles the water a little bit. Sodium has a bigger reaction, and potassium has an even bigger reaction. So just how reactivity is how different things react with other things. This is something we'll also get into when we talk about parts of the periodic table and periodic table trends. So we'll come back to this specific example later on. Now, going into physical chemical changes, these are things you probably have heard in the past, but we're going to go over it again. So in a chemical change, here's just an overview of an example. You have a wood log. It is getting burned, and now you have a pile of ash. It is no longer the log, it is now ash. A new substance is formed. And in physical changes, you have a lemon that is whole. It is cut. And after you have slices of a lemon, it is still the same substance. So based on that, what do you think the difference is between a physical change and a chemical change is? How are they different? So let's get into physical changes. And if you were to look up a textbook definition of a physical change is a change that alters the form or appearance of a material, but does not make the substance anything new. It is still the same thing. Phase changes, this is a big one, are physical changes. So think P for phase, P for physical. Phase changes are physical changes. And so it's going from, let's say, liquid water to solid ice, ice to liquid water. They're both water, they're just in different phases. You're not making anything new. So if you take the word stampedes in that font and you put it through the physical change machine, it's the same word, it's the same thing, it just looks a little bit different. Nothing new was created, physical change. If you take a log, cut it in half, it is still a log. If you have ice and you melt it to water or liquid water, that is a phase change, and a phase change is a physical change. Or just write phase change right here. Okay, there we go. So during a physical change, the properties, these physical properties remain the same. So a substance is the same. It changes the form without changing its identity. So again, melting ice, this is still H2O, that is H2O. If you shred paper, whether it's big piece of paper, small piece of paper, it is still paper. If you mix together different marbles, cool, now you have mixed up marbles. They're still marbles, you're not making anything new. Same with chopping wood. Same thing, just looks maybe a little bit different. Some other examples, crushing a can, melting ice, boiling water. Again, these are phase changes. Mixing sand with water, breaking glass, dissolving sugar in water. This is a good one. because people think, oh, or I'm dissolving salt or sugar in water, I can't see it, I think I created something new. But you didn't, you just created a mixture. And if you can separate those mixtures, that is a physical change. And things we'll get into later on. But dissolving something, like salt or sugar into water, is indeed a physical change because you are able to undo what you did. Okay. Oh, sublimation is another phase change that is solid directly to a gas. Fun fact, which we will get into later on in the year. Now, oppositely speaking is chemical changes, and when a chemical change occurs, a chemical reaction occurs, and a new substance is formed. So we take our stampede example. We have the letters that make up the word stampede. We take all those letters, pull them apart, build something new. Now we have the same letters, same number of each letter, but now they're recombined to form something completely different into new words. Other examples are cooking an egg. So you have this type of egg, and now you have scrambled eggs. You have a bike, and then you have rust. So in each of these things, you've made something new. In a chemical change, again, the identity of the substance changes and it now becomes something new. You've formed a new substance. So here you have in this GIF some sugar cubes with some sort of very strong acid, and the acid is reacting with the chemicals in the sugar, breaking them apart, leaving you behind just that black carbon. So you have stuff you started with that you didn't, you have new stuff that you end with that you didn't necessarily start with. So some examples of chemical change are keywords for chemical changes. So these are some keywords that you might think or hear. Rust, rot, burn, decompose, corrode, oxidize, ferment, explode. These are all kind of more complicated sounding words, and chemical changes are generally more complicated than physical changes because, again, chemical changes require chemical reactions to form new things. Some evidence of a chemical change. So here are some more keywords for a chemical change happening. The color changes, the smell changes, you formed a gas, you formed a precipitate or some kind of solid within a liquid. So you mix these two liquids together and boom, out pops a solid. That happens. You have a change in light, a change in heat. All those things are evidence of a chemical reaction, and if a chemical reaction happens, that means a chemical change happened. Okay, so here are some examples of chemical changes. It's kind of blurry, but you have iron rusting, wood burning, metabolism, cooking an egg, baking a cake, a chemical battery, fireworks, vinegar, and something I can't quite see what that says, a rotting banana, and electroplating. All examples of chemical changes. So, I know we threw a lot of information at you in a relatively short amount of time about chemical and physical changes. So, is this a chemical change or is it a physical change? Physical change. So here are some helpful hints. Now, first question you should ask yourself, did you make something new? If the answer is yes, I know for sure I made something new, that is a chemical change. If the answer is no, you did not make something new, that is a physical change. If you're not sure if you made something new or not, so let's say you have an ice cube and you melted it to liquid water. You're not sure if something's new because ice is technically not water or not liquid water. You're not sure. Ask yourself the second question. Can you undo what you just did? Can you go backwards? So if you can go backwards and undo what you did, that is a physical change. So can you unmelt or refreeze that liquid water or that solid ice? Yes, you can. If you can't go backwards, so if you had take an egg and you crack it and you cook it, can you uncook your egg? No, you cannot. Therefore, it is a chemical change. So this is a super helpful slide for you. Again, these two questions. Did you make something new? And then if you're not sure about an answer for that one, can you go backwards? Okay, so now with that, let's go through some examples together. Ice cream melting in the hot sun, physical change or chemical change? Hopefully you guys said physical change because melting is a phase change. Phase changes are physical changes. You can refreeze that liquid ice cream back up very easily. Burning cookies. What do you think? Physical or chemical change? Hopefully you guys said chemical. When you're burning something, you are changing the chemical composition. That's why the outside of the cookie is now black. It's that leftover carbon from whatever was in the cookie beforehand. And if you're not sure if you've made something new in that, this question right here, can you unburn a cookie? The answer is no. So again, that is chemical. Is this a physical change? Chopping down a tree. Yes, it is a physical change. When you cut down a tree, it is still a tree. So that is a physical change. Baking a cake, physical or chemical? This is chemical. Hopefully you said that. When you bake something, you're turning that liquid batter, and when you put it in the oven, different things react with different things. You have different gases formed. That's what causes things to poof up. That is a chemical change. And again, if you're not sure, can you go backwards? Can you unbake a cake? The answer is no. It is a chemical change. Okay, here we have, I think, our first example of a chemical equation. We have H2O(S), which means solid, going from H2O liquid. So is this a physical change or a chemical change? You start with water, you end with water, and you're just changing phases. That makes it a physical change. This is a phase change, and solid to liquid is called melting. Okay, again, things to look out for. You start and end with the same thing. That is a physical change. Chemical change. Here we have H2, which G is a gas. You have O2, gas, and you're forming water vapor, or gas water, which is water vapor. So, is this physical or chemical? Hopefully, you said chemical, because you're starting with H2 and O2 separate, and you're ending with water. So you're starting and ending with completely different things. This is an example of a chemical reaction. Different things are being formed. So it is a chemical change. So that was a lot of information coming at you. We'll practice this in class, no worries. But hopefully that kind of jogged your memory of what you may have learned in the past about physical chemical changes. And on the next episode, we will cover things called particle diagrams, talk about what they are, how to draw them, and all that fun stuff. So on that note, have a wonderful day.